Yeah, so as before, we'll look at some sample problems. So we are currently in week 6. Do you have any questions? Then I can answer them first before I
No, sir.
start problems.
No, sir.
Okay, okay. Right. So let's. Do you understand Markov chains well enough?
Yes, sir.
Okay. Okay. So let's look at these problems then. So the first problem is we have a Markov chain. P is the transition matrix of this Markov chain, and there's an initial probability distribution which is pi. So then, what can we say about uh, this quantity? Sorry. So is it dependent on first of all, does this limit exist, and is it dependent on pi? So the answer is that it exists, and it's actually independent of pi. So this is a well-known theorem. It's called the Perron-Frobenius theorem. Uh, yeah, if it's possible to go from every state to every other state, which basically means that the transition matrix has all entries non-zero. Um, so then we can say that uh, that that if we allow this stochastic process to evolve, then then at infinity, all the states will have uh, so a stationary distribution would be achieved, and this stationary distribution is independent of the choice uh, of the initial probability distribution. So have you heard about the Perron-Frobenius theorem?
Yes, sir.
Okay. Okay. So let's move on to the next problem. Um, and this again follows from the Perron-Frobenius theorem. Um, so there's a Markov chain with some states, 2021 states. Uh, the stationary distribution is given to us of those 2021 states. Um, Okay. So now, so let m prime equals uh, this limit with respect to some initial distribution pi. Then what is the sum of the first 1024 entries in the 1024th column of n prime? Uh, okay. So would you like to try this question?
So actually, I have I have tried, but I couldn't understand the question.
Hmm. Right. Uh, yeah. So this is more or less like, um, yeah. I mean, so this pi transpose um, m to the power n. This will be a row vector, right?
Yes, sir.
This will be a row vector. Uh, and what is the sum of the first 1024 entries? The 124 in the 1024th column of n prime. Oh yeah, there is some language mistake in this problem. Yeah, it's not correct. Um, yeah, it's not actually correct. Uh,
Sir, there is a similar question like this to the assignment, and it asks
okay.
like the trace of matrix. So can I share my screen?
Yes. Um, yeah, you can share your screen. Go
So
ahead.
like this here it is like what is the trace sum of the principal diagonals of M dash? It is like saying like that.
Be a transition matrix with, yeah. Suppose that the vector is station distribution. Ah, ah, yeah. This is um. Okay. Yeah, actually it will not be pi transpose m to the power n. It will just be m to the power n.
Okay, sir.
Okay, it will just be m to the power n, and then the problem makes sense. So if it is
Okay,
m to
sir.
the power n, so then m prime is a matrix whose every row is this whatever this is given.
Okay, sir.
Okay, every row would be this, and it would have 2024 states, so it has 2024 rows, and then you can basically compute uh, the sum of the diagonal entries.
Like it will be the sum of this only.
Yeah, it will just be the sum of, yeah, like half plus half squared plus half cube and so on.
Okay,
That would
sir.
be the sum.
Okay, sir. Okay,
Yeah,
sir.
right. So yeah, there's a mistake. It should not be pi transpose m to the, it just be m to the power.
Okay, sir.
Let's continue. Okay. So in this problem, we are given a Markov chain uh, where basically given any node, uh, the probability of transitioning from that node to any other node is is a uniform distribution on the degree of that node. So this is basically this problem. Just give me a second. Yeah, so basically it means that if you are at state two, then you have then there is a 1/3 probability from going from 2 to 3, 2 to 4, and 2 to 1. And similarly, so essentially, whatever the degree of the node, the probability of going from that node to any of its neighbors is a uniform distribution on the degree of the node. So that's how a Markov chain is actually created, where given a particular node, the probability of transitioning from that node to any other node is basically that which is listed by the neighbor. So from 1 to half, there is a 1 probability. Um, just give me a second. I just want to be double sure. Yeah. So from 1 to half, there is a 1 probability. From 3 to 2 and 3 to 4, there is half and half. And from 4 to 2 and 4 to 3, there is again half and half. So you can actually form the transition matrix the transition matrix is going to look like this. So I'm using a slightly different convention for the transition matrix. So like uh,
So like said, from 2 to 3, it will be the combination of 1 by 3 and 1 by 2. Like it will be
no,
1
no,
by
no, no,
3.
no, 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 no. From 2 to 3. Uh, so essentially, think about it this way. If you are in node 2, um, so there are three possibilities. You can go from 2 to 1, 2 to 3, 2 to 4. You randomly pick one of them. Okay, so the probability, uh, so let me just write it at each node. At each node, uh, you randomly pick a neighbor to go to in the next time step. Okay. So based on that, you can form a transition matrix. So in the notation that I follow, this Mij is the probability. Uh, Mij is the probability that xt is the probability that xt plus 1 is going to be I, given that xt equals j. So this is my transition matrix. This is how I'm going to build it. Uh, right. So you can actually form the transition matrix. So if you write the transition matrix, so let's number the labels 1, 2, 3, 4, 2, 3. So if it's 1, it goes to 1, 0, 0, 0. From 2, you can go to 1 with a probability of 1/3, 0, 1/3, 0. From 3 to 2, half, equals 0, half. So this is the transition matrix that we have. Now the question asks us if this Markov chain is ergodic and regular. So you have to basically check. So you have to take a few consecutive powers of this matrix M. Uh, Let me just write it down. Take a few consecutive powers. And you can check by inspection if you get such a power where all the entries become non-zero, uh, and or you get at least uh, and as you take the consecutive powers, you have to check if these non-zero entries, if the zero entries become non-zero for some value of n. So that will decide whether the Markov chain is has ergodic property or regular property. So I'm not doing it because I think if you take up to m3 m power 3 over here, I think you'll be able to decide. But yeah, you can do it by yourselves. Uh, so you will see that this Markov chain uh, is both ergodic and regular. So C is Okay. So, so this is one problem where we are given like two Markov chains, two separate Markov chains. So, okay, let me also copy. Hello, I think someone asked me a question. Uh, Kindly suggest a reference book.
Yes, sir. I'm Subhadra from Chennai.
Okay.
No lecture materials are available here, sir. It's very difficult to refer books. No reference books are also not available on the site.
Okay, okay. Ah,
Uh,
okay.
you didn't uh, post these class notes also, sir.
Which class? Oh, okay. So
This
yeah.
online,
So,
this
so
problem
I
solving
have,
session, sir.
yeah. So
No
I have,
material for us to refer if we have some doubt. That's why I'm asking.
yeah. Sure. Yeah. So, I'm having some difficulties in. So, okay, let me give you the link to the YouTube lectures. So I will
Okay.
update them. I think some of the lectures have
Last
not been
but previous
uploaded.
week, you gave two, sir. First
I
week
gave.
and second week.
I can't hear you.
Last but previous week, you gave two lecture links.
Ha. Yeah. So some of the lecture links have not been updated, so I'll update that. I'll update that by today. Um, but when it comes to
Better you
the
update in the site itself, sir. Because so many people are asking. No one have the access to refer any notes, particularly for this
okay,
subject.
so just give me a second.
Okay.
Okay, so I'm having some issue in updating uh, the list. So what site do you refer to? Like when you say
See,
uh,
actually, in the NPTEL itself,
huh,
there is a section called problem solving session. For other courses, every week they are uploading the problem solving session YouTube links. But for
uh-huh,
probability for a computer science, it is not available. Not even a single lecture.
okay.
You see the other
Uh,
courses, they are giving lecture materials also, sir. But here again, no lecture materials are available.
no
No
lecture
standard reference book is
materials.
also not available.
No, so okay, so you have to understand this is I'm not the course lecturer. I'm not
Yeah,
giving the
sir.
course. The course. So when you ask about course textbooks, that's the job of whoever is the course instructor to tell that. Okay,
Yeah, sir.
I can refer you, but it's not incumbent on me to tell you the course material. I will nevertheless. Okay.
Okay, kindly
Now when it
convey this
comes
to
to
the course instructor, sir. But you have only 2 more weeks for exams. For us, it
okay,
is difficult to learn.
uh-huh. So I don't have any I don't have access to the place where I can can you give me a reference, like I don't know where to update this on. So there is this sheet, so just give me a second.
So, did you
uh,
see the other courses, sir?
no,
For example,
I don't check other courses.
okay, last this March, last week I wrote 3 exams. Their lecture materials are also available, sir. Whatever you are giving in the class, they have given it's a notes, lecture notes. Suppose
Okay,
somebody
so
is missing this class
so
now, they'll refer that notes and get the knowledge from that.
sure. So the thing is, so whatever we discuss on, so whatever at least I discuss in the session, I mean, if you follow the YouTube lectures, you get the same, you get the same notes. So I think posting the notes and the videos may be redundant, but there is this sheet. So right now, what is happening is that I'm not able to update this sheet because somehow they have not given me access. So because I don't have access to this sheet, I'm not able to update the links to the YouTube. So I have asked them to give me access to the sheet. I will do it as soon as possible. Uh,
Okay.
so in the meantime, I will, since you are asking this specifically, so just give me a second. Um, you know the access, you know the YouTube link, right? Where you get the videos. It has not been updated, I think, after week 4. I think it's updated till week 3. So week
No,
4,
sir. No,
5,
no,
6.
no. Sorry, sir. Shall I share my screen and show you?
Yeah, go ahead.
One second.
Okay, so when it comes to references for this course, let me just type a couple of references. So Sheldon Ross probability. This is one of the textbooks.
Okay.
Another textbook is Mark Levine. Uh, this is on Markov processes. So this is a detailed textbook on Markov processes by Mark Levine. If you want a book which is more mathematical in flavor, then go for Duret probability. But this might be somewhat advanced, so I'm putting a star. But Sheldon Ross is the most, I would say uh, it's the most basic book. Then Mark Levine has this book on Markov processes. Um, Sheldon Ross also has a textbook on stochastic processes. Yeah. So yeah, of course, not.
Thank you, sir. Thank you.
Yeah. So of course, not all the material in these textbooks would be relevant to the course. You would have to look at the contents of these textbooks and see which of them is relevant to the syllabus of the course and refer to that. Uh, okay, I will update the YouTube lecture videos by today. Uh, so that at least you know it. But when it comes to updating that sheet, so there is this sheet which has the link to the YouTube videos. There seems to be some trouble. I'm not able to update the lecture videos. I have asked them to give me access. There's some access issue. Okay. But do you want to give? But you were saying that you wanted to share the screen. You want, like, can you
Yeah,
show me
yeah.
where
I'm
other
trying,
people
sir.
are uploading?
I'm trying.
Let me
Okay.
see
Well,
that.
one second.
Huh.
Abhishek.
So do you want like a special course? Do you want like a special session? I can take a special session. Um,
Make screen visible, sir.
yeah.
Yeah. See there, only one YouTube link is available, sir. If
Yeah,
you click that link, it
it's
goes to
so
some
what I'm
machine learning
saying
lecture.
so we don't have access. So they have to give us right access to this sheet.
Yeah.
The thing is, the reason why both of us are not able to update is because they are not able to give us the right access to the sheet. So I will ask them to fix this issue, and I'll tell them the students are getting disturbed because you are not able to update the YouTube links. But we will. I will do that. Okay, don't
Okay,
worry about
that
that. I'll do
updated
that
link
as
is
soon as
also a
possible.
false link, sir. If I click
Huh?
it goes to some machine learning lectures. Kindly
Right.
upload
Okay. Okay.
before
No. No. Just give me a
next week,
second.
sir. It is
So this is
very
the
helpful for us to prepare for the
Yeah.
exams.
Yeah. I mean. Okay. Uh,
Shall
so
I
just
stop, sir?
follow this YouTube link. I will. Some of the videos are not updated. I will update that by today. Okay.
Okay.
Follow this YouTube link. This is the other teaching assistant. I don't know what that other person is doing, but you can follow these YouTube link. It's not some of the recent, um yeah, some of the recent ones are not updated. I will do that by today. Um, there you will find the links to the most recent sessions. Okay.
Okay, so
Um,
thanks a lot. Thanks a lot.
if you want, I can take like a special session. So when is the final exam?
Either it is April 19th or 26th, sir.
Okay. So I can take like a special session on sometime after next week.
Okay.
Okay, I can take
Okay.
like a special session sometime after next week where
Okay.
I can see. It depends on how many people are joining. When the sessions I conduct, there are hardly one or two people who join the
Yeah, yeah,
sessions.
yeah.
So
See, in the
naturally,
evening time, it is very
it's
difficult for us to join. That's why if you are
huh?
conducting this after 7, it is for us, it's convenient. We
What
are
is
coming
convenient?
back from office during this time. That's why.
Oh, okay. So when is like a convenient time? So are you a
7
student
after
or are you a
7,
working
7
professional?
after 7.
Are you a student or a working professional?
I am a lecturer working mathematical faculty basically, working in an engineering
Okay,
college, sir. So I know these
I
concepts,
see, I see.
Margot
Sure.
chain, stochastic process, everything. But
Uh-huh.
problems are
Uh-huh.
a little standard level. That's why I'm asking. I can answer all the questions if I know the concept little more. Okay, that's why I'm
Huh.
asking, talking like this.
Yeah,
Sorry for
right.
disturbing
No,
you.
no, that's fair enough. Fair enough. So, see, it depends on the kind of feedback that I get.
Yeah,
So
sir, your
if so,
lectures
it's a
are
good
good.
thing. So you are like the first student who is giving me a feedback
Yeah,
that
your lectures are very good, sir.
no, 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 no.
I have.
So the thing is, I need a feedback. So like, do you want me to explain concepts? Do you want me to solve problems? Do you want me to solve advanced problems? I want this kind of feedback. So because I don't get this sort of feedback, uh, so what happens is that I only end up solving some of the past assignment questions. But if you want like real like advanced problem solving sessions, I can pick these books, Ross Probability, Levine, and I can solve some uh, advanced problems in Markov chains and all that. But it depends on someone giving me feedback. So you are like kind of the first person who is giving me a feedback.
Yeah, I know how to write this transition probability matrix and all. But when you're asking that is an assignment question, problems are little standard. So not, see, we are engineering faculty. Their problems are very basic level only. Okay. So that's why we are finding answers. Most of the answers are close to each other. So that's why we are finding difficult in getting the correct answer. Okay, that's why I'm
Okay.
asking notes and lecture notes and problem solving session notes. That's all. Why?
Yeah, but the thing is, those notes will not really be very useful because so when so for instance, you would have seen that I was discussing these problems, but when discussing these problems, I'm not writing them down fully as a note. So I'm
Yeah.
saying a few things and then I'm writing a few things, again saying a few things, writing a few things. So it's
Yeah.
not a full-fledged note. Okay. But if you follow the lecture video,
Yeah. That is
along with
only
it,
helpful for
then
us.
it makes sense.
Yeah, yeah,
Okay.
yeah.
Uh, so it's so I would what I would suggest is to just follow the section the session videos which I'll make available very shortly. To just follow that. I will not be able to give you full-fledged notes. However, I am planning to conduct uh, an extra session for maybe like 3 more hours, or yeah, maybe like a 3 hour extra session. And if you're willing to join, then yeah, then we can discuss some uh, we can discuss different types of problems. It depends on what you want.
Okay.
Do you want me to explain some concepts better? Do you want me to what do you want? I'm asking you. Are there any
See,
specific concepts you want me to touch upon?
yeah, I know the concepts, basic concepts I know very well.
Huh, huh.
Okay, I want to discuss more problems. That's all.
Okay, fine,
Okay.
fine. We will discuss more problems then.
Because I am a
So,
mathematics faculty, I know the concepts.
sure.
But problems are little difficult for me in my knowledge.
Okay.
For others, maybe it is easy.
Okay.
Okay.
Yeah. So what? Yeah. So let's discuss some advanced problems. Um, you can email to me. This is my email ID. Uh, yeah. I mean, this is the kind of interaction I want. But of course, um, so this is my email ID. If you have any
Okay.
problems, feel free to reach out to me. I'm a bit busy till April 5th. I have a deadline at that time. But
April?
after April 5th,
Okay.
5th April.
Okay.
But after 5th April, I'll start having more time. So if you have specific problems, feel free to reach out to me in this email ID.
Okay.
And okay, so I'll start. I'll conduct a special session. So NPTEL has given us a chance where if we want, we can take some extra sessions. So yeah, maybe because that's in demand, I will set up an extra session. So when is the time that is convenient? Okay, I mean, when is the time that is convenient? Is it
7 or
convenient in the
after 7
evening?
is it in any day it is convenient for us.
Okay, so maybe I'll set it up like around.
If not, you
How
arrange your
about
convenient
Saturdays?
time, sir. I'll definitely make myself available.
So
You
how
do
about
your convenient
Saturdays?
time, sir. It is for our sake only you are doing. Okay. So I'll make
That's
me
okay. That's okay.
the
So
time.
how about Friday? So Friday I have my regular session only. If I want like a separate session, how about Saturday? How about
Is it
Saturday?
okay? Okay. Saturday is okay. Good. But we people are working on Saturdays also.
Oh, okay, okay. So
Okay,
Saturdays
no, okay,
you
sir.
don't get
You
like
arrange it on Saturday.
Okay, so Saturday is 7 p.m. Let's
Saturday,
keep it
7
at
p.m.
Saturday 7.
Okay.
Uh, I will reach out to NPTEL and I will ask them how to set it up. Okay. So
Okay, okay. Thank you.
I'll ask them to broadcast a message on this, so you will get the information. But this is going to be after April 5th. So probably, yeah, not on April 6th. It can't be possible. April 6th is a Saturday, but April 6th I won't be able to conduct the session. Um, um,
Then fix it on April 5th, sir.
uh,
Fix it on April 5th itself.
April 6th? No, April
5th,
6th,
5, 5,
I'll have
5, 5.
April
The
5th.
5th.
Huh?
5, sir. April 5th. Next Friday.
No, next Friday I have a deadline next Friday.
Okay.
I'm going to be busy till next Friday. Even on Saturday I'll be busy.
Okay.
How about
So then leave it, sir. I'll go through the books, and if I have any doubt, now I'll mail you. Email you.
uh, how about a session on Monday? I don't know. Monday.
Oh, no problem.
Monday 7 p.m.
Okay,
Yeah,
Monday,
Monday
7 p.m.
7 p.m. I'll set up an extra session. So
Okay.
Monday, so let's keep it at Monday 7 p.m.
Okay, okay, sir.
Okay.
Okay,
Okay.
thank you.
Yeah, and I will update this YouTube link so you will get the more recent sessions. I'll do it by
Okay.
today.
Okay, okay. Thank you. Thanks a lot, sir.
Okay. Right. So where were we? Okay. Yeah, so in this problem we have, so let's discuss, this is going to be the final problem of today. Yeah, I mean, feel free to reach out to me if you need like if you want any specific problems to be solved. So, okay, so we have this Markov chain over here. So if you look at this Markov chain, there are two end states. The first Markov chain has two end states. So E and A are called end states in the sense that if you reach A, there's no way you can reach any other state from A. So you will see that from A, there is the probability that you go to any other state is 0. So A stays at A with probability 1. Similarly, E stays at E with probability 1. Okay, so we are calling these states as end states, something like that. Similarly, this next Markov chain, there is only one end state, A. Okay, none of the other states are end states. So the question is a basic question only. It basically asks us which of these Markov chains. Yeah, so if you take this first Markov chain, whichever state you are in, you can basically go to one of the end states. So if you look at this first Markov chain, if you are in state C, you can go to E. Similarly, if you're in state D, you can also go to E. If you're in state B, you can go to A. So, so these special kinds of Markov chains are called absorbing Markov chains. It's what is the terminology of the question. I don't think it's a very popular term, but anyway. So it's an absorbing Markov chain. So the first one is an absorbing Markov chain. The second one is not an absorbing Markov chain because from some of the states, so you can, the only absorbing state is A, and you can get to A only from B. But if you're in the states C, D, and E, you cannot get to B. Okay. So this is not an absorbing. Okay, I'll stop the session here today. Is it fine if there are no further questions? I'll stop the session here. Okay.
Okay, sir. Thank you.
Okay, great.
Thank you. Okay.